central tendency today, which we also call the measures of location. They include the mean, median, mode. So sometimes we put range, and sometimes we put it under dispersion. But whatever situation, we should know that mean, median, mode are the basic measures of central tendency. The mean is a measure generally referred to as average, commonly referred to as average, and that is why we have some types of mean. We have the arithmetic mean, and then we have the geometric mean. The arithmetic mean is a value that you calculate as a representative of the a population. Say if you have observations altogether, one particular value that can stand out for them is what you say an arithmetic mean. The others revolve around it, and the arithmetic mean, which is generally known as averages in sometimes, is given as mean x bar is sum of x divided by n. The x are the observations, let's say the age of students: 19, 21, 18, 14, 17, 15. These 6 students, we need their age. We say find the arithmetic mean. What is the average among these numbers? Remember, your x values or your observation value can also be a frequency value. Let's say, for example, how many students are in categories of ages, age x. How many students are there in this particular class? Let's say in the class we have 18, 19, 20, 21, 22. These are the ages of students. Then we now have the number of students in a particular age, number of students, which we call frequency. So let's say 5, 6, 18, 12, and 3. So by the time we add the frequencies together, it will tell us the total number of students we have. So this will now change the formula to summation f, and then in order to know how to calculate the mean for this situation, each frequency will be multiplied by the age group. We call it fx. Thus, this becomes summation fx. So if you are dealing with information that only looks at one value at a time, your mean is summation x over n. And if you are looking at frequency observation, then your mean is what do you call it? Summation fx over summation f. Another type of mean, harmonic mean. Harmonic mean. All these are what we want to do at. As an example, your geometric mean, which is given as the product, the square root of the product from I equals to 1 to n of your xi. And if you are dealing with frequency observation, you have to say summation fx over summation fi. So that is for the geometric mean. The product, the art product or the height product of this one. Let's say you have high observations. So this one, all this can be easily obtained when you have your packages. So sometimes for frequency observation is the summation f root of the product I equals to 1 to summation Fxi. You multiply each value by what? The frequency, you get it, you multiply together, and this one. But on your packages, you can easily obtain the geometric mean. What about the harmonic mean? What about the harmonic mean? It is used when you are dealing with rates. It is used when you are dealing with what? Rate. The harmonic mean measure rate. So harmonic mean, which is what? N over 1 over summation xi. N 1 over summation xi. Or you say summation of 1 over xi if you don't want that one. Summation 1 over xi. So this one deals with information that are consecutive, while this one deals with rate. So all you need to just do is put in your values, and when you put in your values, your n will be the number of observations, your x's are each of the values. Okay, the other measure of central tendency, the median simply means the middle observation. Which of these observation is at the middle? We say that is what? Median. So if you have, for example, the ages we have here now of 6 students in a particular class, we just ask 6 students what are your age, and they gave it to us. What we need to do is to first arrange in a specific order. It can be descending or ascending. Okay, if it is descending, 14 is the first one that will come. So this information will be arranged as 14, 15, 17, 18, 19, 21. We now say which are the observations at the middle. If you look at it, you have 6 observations. If you take one here, you make 4. Another one here, you make 2. If you take the 2, nothing will be at the middle. Then you say the median in this place is the addition of 17 and 18 divided by 2, which will give you 17 and a half. If this is in years, put the sign. But if we are dealing with observation that is what? Odd observation, you have 1 at the middle. Let's say these are 9. Number 5 will be at the middle. 19. Number 9 will be at the middle. The median will just be the direct value. Okay? But if you are dealing with frequency observation, just like we have 18, 19, 20, 21, 22, and the number of students as this, the median can be obtained by looking at the total frequencies. Let's say, for example, total frequencies in this case now, summation L, 5, 6, 11, plus this one, 29. If you add this, it becomes 32, and plus 12, 44. It means we have 44 observations. If I have 44 observations, 44 items, and I want the middle, you can say, oh, let me divide it into 2. And 44 divided by 2 will give me 22. So 22 observation. And how do I trace number 22? Simple. Just keep adding. 5 plus 6, 11, plus 18, that's 29. Which means number 22 is already falling here. You can see, oh, 20 is our median. Easily. Median equals 20. But we also have another form of observation, and that is what? When we are dealing with frequency, group frequency observation. Group frequency observation. That is, the age can now be in brackets. Those that fall between age 5 and 10, 11 and 15, 16, and so on. If we now have that kind of situation, group frequency data, median is LB N over 2 minus summation F subscript N divided by F median multiplied by C. LB is the lower class boundary of the median class. N is the total frequency or summation of the frequency. Summation F subscript N is the sum of the classes. Summation F subscript N is the sum of the classes before the what? Median class. F median, so frequency of the median class, and C class weight. If we obtain our information from that form of table, we substitute it into this. We say we have the median for this observation. Okay, the mode is a simple observational measures of central tendency. The mode, if say mode, the one that occur most, the information that appear most times. If you look at this our information here, 14, 15, 16, 17, 18, none of them appear beyond 1. So we can say each of them are sharing mode or there is no mode. But suppose among these 8, perhaps we have another student and the student said his own age is 18. You know, in this situation we are now having 2 18s. 18 become our mode. But for this frequency observation, if we look at it, our mode can easily be gotten as the one that has the highest frequency. Age of student 18, 19, 20, 21. 21 has the highest frequency. 20 has the highest frequency. 18. We say 20 is the mode in this situation. But for a situation whereby it is classed, we say mode is LB Fm minus Fm minus 1 divided by Fm minus Fm minus 1 Fm minus Fm plus 1. Remember, these M are in subscript, and then C is the class width. Okay, LB is the lower class boundary of the modal class. What do we mean by the modal class? The modal class is the class that contains the mode, and the class that will contain the mode will be the one that has the highest frequency. If our information here, let's say for example, is now in interval, let's say 5 to 10, 11 to 15, 16 to 20, 1 to 25, and finally 26 to 30. Let this represent information, maybe the number of students that comes to a particular class in the university. This is the information we have. If we look at it, the highest frequency here is 18, and the class that has the frequency is 16 to 20. So this class will be called the modal class. LB is now the lower class boundary. And class boundary is different from class interval. 16 here will be class interval. The class boundary will be when you remove 0.5 from here, 15.5. So LB will be what? 15.5 for this question. Also, FL, frequency of the modal class, 18. F subscript M minus 1, frequency of the class before the modal class. So this is the modal class. This is the class before the modal class. The frequency is 6. You put 6 here. So the same thing here, 18, 6. Then in this one too, 18 again. Fm plus 1, frequency of the class after the what? The modal class, which is 12. C is class width. And to obtain class width, remember from 5 to 10, you have 6 observations. If it is confusing, count it. 5, 6, 7, 8, 9, 10, 6. So your C is 6. If you want to do the same, you can do the same for this median. LB 15.5 for this situation, because this thing has the same class as the median. N over 2. N is 44 divided by 2. 22. Summation F subscript L means sum the frequency of the class before the median class. In this one, 5 and 6, 11, and then 21 to 25 is the other one here. Okay, we don't need it. Frequency of the median class or frequency of the median, that is 18, and then class width as usual is 6. By substituting these values, you'll be able to obtain your median, and if it is mode, you'll be able to calculate that. Alright, so those are some measures of central tendencies. Those are some measures of central tendencies. So in continuous, we can also have what we call some measures like quartiles under measures of location. Quartiles, I will advise you to look at that. Deciles and percentiles. Quartiles, deciles, and percentiles. You can ask for regard to those ones. Alright, measures of dispersion. Measures of dispersion, which you can also say they are measures of variation. Measures of variation. Okay, what are measures of dispersion? They are measures that shows us how our information are closely related. The data we collected, does it look like the information that what looks the same, or they are far apart from each other? Those are our measures of dispersion. So in our measures of dispersion, which I said can be termed as measures of variation, if you like, we have the mean deviation, the variance, standard deviation, coefficient of variation, and as well as coefficient of standard deviation. All right. Then under this, we still also have measures of clarity or variation. But let's look at this one first. Mean deviation, MD, is a measure that takes absolutes. A measure that takes absolute of a value from its main value divided by n. If it were to be frequency of observation like is shown under measures of deviation, we say summation f, absolute of x minus x bar over summation f. What you are saying is that if you have observations, let's say each like the other time, or we say class interval. Our class interval 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49. Let's say we want to use this 5. And then we have their frequencies. Let's say this is 2, 3, 5, 3, 1. So let's say these are the frequencies of our observations. The first thing we need to do is find x, mean value x. That is, what is the median value when you add the two values of the class interval and divide by 2. So this will be 4.5, this will be 14.5, 24.5, 34.5, and 44.5. And add these together, 5, 10, and then 14. So if you need the mean deviation, what you need to obtain first is the mean. So you need fx, multiply frequency by what? Each of the main value. Here you have 9.0. This 0.5. There's 4, 12, 13, and this 3. This will be 5. And this will be 20, 25, 10, 1, 2, 5. This will be 0.5, 12, 13, 10. And the last one 44.5. So if we add everything together, our main, as usual, summation fx over summation f, we have a main. So after we have the value for main, we now subtract each value. We subtract the main from each value and then take the absolute. Absolute means that whatever you have, turn into positive. If it is positive, let it remain. If it is negative, change it to positive. So you add everything together, you multiply each one by frequency and add together, then you get your main deviation. That is how to obtain our main deviation. The variance. If you need your variance, you say use. Variance is the most widely used information. Summation x minus x bar squared over n for single observation, or summation fx minus x bar squared over summation f. So it is quite similar to main deviation. The only thing different is that once you find your x minus x bar, you now square it. X minus x bar squared, you now square it. If you notice the information under measures of dispersion, none of them would be what? Negative. Because by the time you change all the negative to positive, you will not have negative number. And by the time you square this, you have the what? You have all positive values. For this one, it may be like. All this can be easily obtained when you use a packet like SPSS or so. Alright, standard deviation is the square root of variance. Just calculate your variance in any situation, and when you calculate it, just put it in the square root, you get your standard deviation. Coefficient of variation, that is standard deviation over mean. Coefficient of variation, standard deviation over mean. Coefficient of standard deviation, that is standard deviation divided by mean multiplied by 100. That is coefficient of standard deviation. All these measures are for what? Are for measures of variation. Measures of variation. Okay. So all this we can practice if we have the time. Then we need to talk about something under measures of deviation, measure of standard deviation, and which is what we refer to as skewness and kurtosis. Skewness and kurtosis. Okay. Skewness. What do we mean by skewness? Okay, maybe I can retain my example. Skewness is a statistical number that tells us what? If a distribution is symmetric or not. Okay, that's another word, symmetric. What we mean by symmetric is that a distribution, the data we have is a mirror of itself. Are you getting that? Okay, maybe not. So, if its distribution is symmetric, like if you are looking at the mirror, you see the opposite side of yourself. So this information is symmetric if we can obtain a kind of bell-shaped normal distribution. So to show whether our information is symmetric or not, the distribution is symmetric, the skewness is going to be 0. The distribution is symmetric, the skewness is going to be 0. But if it is more than 0, let's first write the formula. x minus x bar cube over n minus 1 s cube, where s is what? Is our standard deviation. Where s is our standard deviation. You can put it there. Where s is standard deviation. So, if you want to calculate skewness, just like you have this table well prepared for standard deviation, variance, mean deviation, and so on. If it were to be a situation of frequency data here, you still need an additional column, x minus x bar raised to the power 3. Then a third column because you are dealing with frequency. That is why if you were to be for frequency observation, we say skewness is summation f x minus x bar cube over summation f minus 1 multiplied by s cube. So you still need an additional information to get this one. X minus x bar cube, so you get it by what? Doing the difference once and then multiply the answer by itself 3 times. S cube, from your standard deviation, you multiply it by itself 3 times. Summation f minus 1, the frequency remove 1. So you see that our information is mirrored towards the right or mirrored towards the left. If skewness value is 0, we are dealing with normal distribution, and in that case the main, median, and the mode are the same. Main, median, and mode are the same. That is when our skewness is going to be what? Skewness is 0. But if the skewness is greater than 0, information is right skewed or righting. That means our information falls towards what? It falls towards the right hand side, positively skewed. If it is less than 1, it is negatively skewed. Variance and skewness are not the same. Variance tells us the amount of variability, while skewness gives the direction of variability. Variance tells us the what? Amount of variability, while skewness gives the direction of variability. Then measures of variation have greater practical application, but in medical life, that is where we use what we call as skewness. What about kurtosis? What about kurtosis? Kurtosis is a measure that tells us how far, a particular number, how far a bird shape is taller or lower to what? Normal distribution. How far it is what? Taller or shorter to the normal distribution. Its calculation is similar to that of skewness. Its calculation is similar to that of skewness. We say kurtosis. Kurtosis is summation x minus x bar raised to the power 4 over n minus 1 s raised to the power 4. And if it is frequency observation, we see what? It is summation f x minus x bar over raised to the power 4. So if the kurtosis is less than 0, then the distribution is flatter than the normal distribution. It is flatter than the normal distribution. If the kurtosis is greater than 0, the information has a higher peak than the normal, is taller than the normal distribution. But if kurtosis is 0, it means that what? The distribution is similar to what? The normal distribution. So calculating skewness, kurtosis are important in medical statistics, but in general, the variance, which is the major work of anybody trying to see how related information is, should be taken out. So this is good. Try to check whatever you have done on your own. Thank you for your attention.